Hello everyone, I once again welcome you all viewers and especially my dear student to this online class organized by the State Council of Science, Technology and Environment. Today's class will be the continuation of class of the chapter Some Application of Trigonometry, that is chapter 9, and I will be doing some exercises from the textbook. So let us begin. The question is, a vertically straight tree 50 meters high is broken by the wind in such a way that its stump just touches the ground and makes an angle of 60 degrees with the ground. At what height from the ground did the tree break? Okay, let us first draw a figure. A vertically straight tree. Let us draw a tree. Okay. 15 meters high, which means the height of this tree is 15 meters. Okay, the height of this tree is 15 meters. Okay, is broken by the wind in such a way that it's broken by the wind. When the winds come, alright, this tree break. Okay, suppose this tree break at this point, alright, in such a way that its top just touch the ground. This is the top of the tree, right? This one will touch here. Okay, when the tree break, it will bend like this, right? So let me draw another figure. It will be like this. This is the ground, right? So, and makes an angle of 60 degrees with the ground. So here the angle will be 60 degrees. Alright, now we have to find at what height from the ground did the tree break. This is the ground. This is the part where the tree break. Alright, so we have to find this height. Okay? Okay, let us draw a proper figure. Suppose this vertical line is a tree. Okay, this is 15 meters. This is 15 meters. When the wind comes, suppose this tree break at this point. Suppose it break at this point. Alright, so it will bend like this. Then this top will be here. And this is the ground. Alright, this part is equal to this part. Right, you can see from here, this part is equal to this part. Right, okay, and makes an angle of 60 degrees with the ground. So this angle will be 60 degrees. Let us denote here by A, here by B, here by C, and here by D. Okay, AD is the height of the tree. Okay, by question we have to find the height from the ground that did the tree break. Alright, so we have to find AC. Okay, now we have to find this height AC. We have to find this height. Right, let us denote AC by H. Then AC is equal to H. Okay, if you look at this figure, AD is equal to AC plus CD. Right, AC plus CD. Now, AD is 15 meters, the height of the tree, 50. AC here we denote by H. So let us put here H plus CD. In the next line, we will get 15 minus H is equal to CD. Alright, so CD here is 15 minus H. As I've said that CD is equal to BC. So BC also will be 15 minus H. Alright, we have to find AC, we have to find H. Okay, now in right triangle ABC. Let us draw. This is a right triangle ABC. Here AC is H. Theta here is 60 degrees. And BC here is 15 minus H. Alright. So we have to find this one. We know that from from trigonometric ratios that sine theta is given by perpendicular by hypotenuse. So here let us use sine theta. Sine theta is given by perpendicular by hypotenuse. Okay, and the angle here theta is 60 degree. Let us put here theta by 60 degree. Plus perpendicular here is h, right? And hypotenuse here is 15 minus h. Alright, now sine 60 degree is how much? Root 3 by 2. Alright, then h by 15 minus h. Okay, in the next line you will get root 3 into 15 minus h equal to 2h. Let us multiply root 3 inside the bracket. You will get 15 root 3 minus root 3h is equal to 2h. Alright, let us carry this root 3h to the other side. You will get 15 root 3 is equal to 2h plus root 3h. Let us put the value of root 3 by 1.73. 15 into 1.73 is equal to 2h plus 1.738. Alright, if you multiply 15 into 1.73, you will get 25.95. Okay, and if you add these two, you will get 3.73h. Alright, now let us bring this 3.73 to the other side. You will get 25.95 divided by 3.73 is equal to h. Alright, now to divide this one, you see that there is a decimal point here. Alright, let us first remove this decimal point. We know that 25.95 can also be written as 25.95 divided by 25.95 divided by 100. Okay, and 3.73 can be also written as 373 divided by 100. Okay, here you see here the decimal point is vanished. Okay, so let us cancel 100. Then you will get 25.95 divided by 373 equal to h. Alright, if you divide this one, you will get 6.9 equal to h, which imply here h is equal to AC, which imply AC is equal to 6.9 meter. So we have got the value of AC. So this is the answer. Okay, from the top of the building 15 meter high, the angle of elevation of the top of the tower is found to be 30 degree. From the bottom of the same building, the angle of elevation of the top of the tower is found to be 60 degree. Find the height of the tower and the distance between the tower and the building. Okay, let us first draw a figure. From the top of the building 15 meter high. Okay, let us first draw, suppose this vertical line. Alright, this is the building. Okay, suppose this vertical line is a building. Right, 15 meter high, which means the height of this building is 15 meter. Alright, now the angle of elevation of the top of the tower. What is the angle of elevation? Okay, suppose if I stand here, alright, if I look straight, then this line is called the horizontal line. Suppose this is called the horizontal line. If there is a point here, this point, if I look at this point, suppose there is a point here, right? If I look at this point, then this is called the line of sight. Alright, then the angle between this horizontal line and this line of sight up to the object is called the angle of elevation. Right? Okay. From the top of the building, the angle of elevation of the top of a tower. So there will be a tower here. This is the tower. From the top of the building, this is the top of the building, right? The angle of elevation of the top of the tower, this is the top of the tower. Okay, the angle of elevation is found to be 30 degree. So here is 30 degree. Alright, now from the bottom of the second building, this is the building, this is the bottom of the building. The angle of elevation of the top of the tower, this is the top of the tower, is found to be 60 degree. So it will be like this. Here it will be 60 degree. Alright, now find the height of the tower and the distance between the tower and the building. This is the building, this is the tower, right? So we have to find the height of the tower. We have to find this height and the distance between this building and this tower. Right, let us first denote the points. Here by A, B, C, D and E. Okay, now we have to find this AB and BD. Okay, from the figure, BD is equal to BC plus CD. BC plus CD. Alright, now if you look at this figure, right? If you look at this figure ABCE, this is a rectangle. Alright, in the rectangle, we know that the opposite sides are equal. Alright, now here AE is equal to 15 meter. So BC will be 15 meter. Okay, let us denote this AB by X. Let AB is equal to X. Alright, now if AB is equal to X, then EC also will be equal to X. Alright. Let us denote the length AB by X. Alright, so EC will also be equal to X. Alright, now let us denote DC by Y. Okay, now we have to find the height of the tower, which is BD. Okay, and the distance between the tower and the building, AB. Okay, now from this figure, BD is equal to BC plus CD. Right, BC is equal to 15, CD is equal to Y. So BD will be 15 plus Y. Okay. Now, in triangle, in right triangle, let us take this right triangle first. DEC. DEC. Here is 30 degree, right? EC here is X and DC here is Y. Alright, from trigonometric ratios, tan theta is given by perpendicular by base. So let us use tan theta here. Tan theta is equal to perpendicular by base. Okay, then in next slide, we write tan 30 degree is equal to Y by X. Tan 30 degree is 1 by root 3 is equal to Y by X. Alright, now in the next line you will get X is equal to root 3 y. Okay, let us mark this equation by equation number 1. Okay, now let us consider this right triangle ABD. Okay, next in right triangle ABD. here is 60 degree, EB here is X, and BD here is 15 plus Y. Okay, 15 plus Y. Let us use again by tan theta is equal to perpendicular by base. Then in the next line we will write tan 60 degree is equal to perpendicular here is 15 plus Y by X. Tan 60 degree is root 3 is equal to 15 plus Y divided by X. Right. Then in the next line you will get root 3x is equal to 15 plus Y. From equation 1, x is equal to root 3y. Let us put the value of x equal to root 3y here. Okay. Substituting the value of x. Let us give this equation by equation 2. In equation 2, we get root 3 into root 3y is equal to 15 plus y. Root 3 into root 3 is 3. So 3y equal to 15 plus 1. Right. Now 3y minus y is equal to 50. Alright. Then 3y minus y will be 2y is equal to 50, which implies y is equal to 15 by 2, which implies y is equal to 7.5. Okay. Now we have got DC. DC is, which implies DC is equal to 7.5 meter. Okay. This is the height. BD is the height of the tower, right? Now, BD is equal to 15 plus y from here. 15 plus y. Y is 7.5. So, BD is equal to 15 plus 7.5. So, you will get 22.5 meter. So, the height of the tower is 22.5 meter. Okay. Next, we have to find the distance between this building and this tower. Okay. Which means we have to find x. Alright. From equation 1. X is equal to root 3y. Okay. Then in the next line you will get root 3 into y is 7.5. Alright. Now let us replace root 3 by 1.73 into 7.5. Okay, which implies x is equal to 12.98. If you multiply this, you will get this one. Alright. Now x is AB, which implies AB is equal to 12.98 meter. So the distance between this building and this tower is 12.98 meter. This is the end of this chapter. I hope that you have understood these two problems that I solved. Please do practice the remaining problems. And so thank you so much. Stay safe.